Assalamualaikum warahmatullahi wabarakatuh. Me and my friend will present about the assignment of conduction graphical analysis on heat transfer for course BEEI 2463 Thermodynamics and Heat Transfer. So first of all, my name is Nuraini Syuhada binti Suzaimi, B0821101147.
My name is Nur Erina binti Ahmad, B0821100007.
My name is Nur Sabrina binti Khairul Azhar. My metric number is B082110364.
Hi, my name is Syasya binti Suhaimi, B0821101122.
So the objective of this assignment is to compare the thermal conductivity of copper and alloys for heat transfer fin surface, then provide an understanding of how material selection impacts heat transfer efficiency, and then enable informed decision making regarding the choice between copper and alloys for fin surface materials. First, understanding of heat transfer. Heat transfer is the energy exchange between materials which is solid, liquid, gas as a result of a temperature difference. The thermodynamic free energy is the amount of work that a thermodynamic system can perform. So there is two heats, which is thermal energy and kinetic energy. Thermal energy refers to the energy contained within a system that is responsible for its heat is the flow of thermal energy, while kinetic energy is the energy motion observable as the movement of an object or subatomic particle. Every moving object and particle have kinetic energy.
Okay, there are three main types of heat transfer, which are first conduction, second convection, and third is radiation. Okay, for conduction is the heat transfer that takes places due to the difference in temperature. Heat transfer in conduction is the slowest. For example, Mercury is the closest planet to the Sun and the smallest of them all. Second, convection. Convection is heat transfer occurs due to the difference in density. Heat transfer in convection is faster than conduction. For example, Venus has a beautiful name and it is the second planet from the Sun. Okay, third is radiation. The heat transfer occurs in all objects with a temperature greater than 0. Heat transfer in radiation is the fastest from conduction and convection. For example, despite being red, Mars is actually a cold place. It's full of iron oxide dust.
Introduction of assignment. First, conduction. The hot region contains molecules with higher kinetic energy representing higher temperature. The cold region contains molecules with the lower kinetic energy representing lower temperature. The transfer of heat occurs through direct contact between the hot and cold regions. Other molecules transfer energy to cooler molecules through collision, causing kinetic energy. This process continues until thermal equilibrium is reached with temperature analyzing. Next is fin surface. The fin surface are surfaces that extend from an object to increase the rate of heat transfer to or from the environment by increasing convection. The amount of convection, or radiation of an object determines the amount of heat it transfers. Next is heat sink. Heat sink is a piece of metal that sits on top of a computer chip such as a CPU and draws power away from components by letting it rise through a series of fins. By themselves, heat sinks are passive, meaning they have no moving parts.
Okay, next is specification and design. These are the specification given for the task for design 1 and design 2 of fin surface. Next is result for design 1. The result for design 1 is called triangular fin. Material that used is alloys. Based on this slide that showing two graphs. For the first graph, showing noise versus temperature, and the other one is temperature versus heat flux. Both also show some characteristic which is increaser. The colorful design show the thermal analysis. So we can read the temperature in Kelvin for the maximum and for the minimum. For example, 319.41 Kelvin and 319.11 Kelvin. The back design picture is the sum diagram for the heat flux that we use based on the procedure given.
Next, we're going to talk about the result for the design 2. Design 2, this is a double fin type. We're using the copper material. So we can see for the slide, we can see the two graphs. on it. For the first graph shown the node versus the temperature. For the second graph shown the temperature versus heat flux. Both graphs show the same characteristic, which is both increase. We can see also the two models with the different colors. The different colors for the first one with the virus color show the thermal analysis. So we can see the different colors, and you can see at the side the colors with the temperature. And the second one, this is the model with the copper surface. Going to talk about the discussion and conclusion for this assignment. The discussion for the assignment for the first is the thermal conductivity. Copper is renowned for its exceptional thermal conductivity, which is significantly higher than most alloys. It has a thermal conductivity of approximately 400 watt per kilometer Kelvin, making it an excellent choice for efficiently transferring heat from the hot side to the surrounding fluid. Alloy, on the other hand, can vary in their thermal conductivity depending the specific composition and properties of the alloy. While some alloy may have comparable thermal conductivity to copper, others may have lower thermal conductivity, resulting in less efficient heat transfer. Second, the corrosion resistance. Copper has a good corrosion resistance, particularly in neutral or slightly acidic environment. It forms a protective oxide layer that helps prevent further corrosion. However, copper can corrode in certain aggressive environments, such as those with highly acidic solution or exposure to certain chemicals. Alloy, especially stainless steel or nickel-based alloy, often offer superior corrosion resistance compared to copper. They are more suitable for application where corrosion is a significant concern. Next, the conclusion for this assignment. In summary, copper offers excellent thermal conductivity and a good general-purpose corrosion resistance, making it a popular choice for thin surface. Alloy, on the other hand, can provide a broader range of mechanical properties, corrosion resistance, and high temperature capabilities. The specific requirement of the application, including heat transfer performance, durability, corrosion resistance, and cost consideration, will guide the selection between an alloy or copper for the thin surface. That's all from 4 of us. Thank you.